Hello guys, in this video we're going to go over the rest of components in this engine assembly. And now let's start with something inside, such as this stroke. Let's open it up. So this is the configuration of the stroke. You can see it looks like a link, has a big small circle on top and a bigger circle, bigger half circle at the bottom. And let's try to make this part. Actually, let's go to find out what they did in the first step. So the first step is really make a linkage. Let's get the dimensions. The smaller circle is 0.5. The bigger circle is 1. And then it has then two more circles that 1/4 inch offset it. So 1/4 inch bigger in radius. And the center distance is 4.25. And let's make this sketch first. So let's choose front plane and start sketching circles. Actually, before that, let's make a vertical center line. So we can align the two circles perfectly vertical. So actually, let's draw the first circle from the origin. So let's have this as 0.5 and draw another one down below and set it to 1. The center distance will be 4.25. Okay. Since we have two circles, we can try offset entities to see what they gave us. So for this one, we want it to be 1/4, right? 0.25 as showed in the previous model. And same thing for this one, 0.25. Click yes, and we got two set of circles. And now draw a straight line, connect them from tangent to tangent. All right, so we have this feature. Look exactly like what we saw in this model. And let's find out the thickness of this extrusion, which is 1/4, and from meet plane. And let's do exactly the same. So 1/4 respect to the meet plane. Okay, now we're gonna select contours. We want that one of these, and this. All right, the entire linkage, and let's choose meet plane and have this to be 1/4. Click yes, and here we go. Yep, look very good. And now next step is make it thicker for the rod connection area. So let's find out the dimension of this sketch. So pretty much they use the same set of the two set of circles with additional line that is 1/8 offset from the edge. So let's repeat it to draw this sketch right on the center plane that we just create our extrusion. So the center plane in this case is the front plane, as you can see. I rotate it this way, and let's start sketching from here. Okay, set it normal. First circle, same as there, and the second circle, the same. And let's keep going. Yep. So two set of circles are completed. And now we just need to offset this edge to be 1/8 inch apart. So we can use offset entities right here. Click that and select this edge. And you can see the preview is towards the left, but we want it goes right, right? So let's set this to be negative 0.125. So it will shift the direction. And click yes, and offset the other side, and it automatically makes you the same magnitude for distance. And now let's trim the entities that we don't want. All right. Oh, one more thing. We forgot to convert the outside sketch because in order to extrude, we need a closed region, right? So yeah, so we need to have the outside bound sketch as well. So here we go. We have the closed region, and we can extrude from here and make this be plane as well. And I believe the thickness is 0.5, if I remember correctly. So let's set it 0.5 and let's verify later. So click yes. And the thickness in this original part is 0.5, distance of 0.5. So we got it right. And let's go over to the next step. So one extrusion from left side. And what is dimension? So at this point, from this edge we just made, which is offset at 1/8 from the outside surface. So this rectangle intersect with this point and gonna be vertical and has a dimension of 1.25 by half and same thickness. Okay, and one of the angle is intersect with the bottom arc. Okay, let's do that. Do that again. 1.25 and a half. Alrighty. Okay, so steel. Let's draw on the middle plane and start sketching from here. Let's make a rectangle. So that will be like this. Let's dimension this 1.25 and a half. Okay, I think I made it wrong. Let's get rid of it. And redo this. Okay, so it seems like we should go up, right? Let's make this 1.25, this 0.5. And this line and this point should be coincide. Yes. This point and this edge need to be coincide as well. Okay. Alrighty, and let's extrude this to have the same thickness. mid plane and 0.5. Okay, here we go. And the next one is a cut extrude. So 3/8 as diameter. And a quarter deep. So 3/8, 0.38 as diameter. And let's make a center line about this edge. So we can align this circle in the center line to be coincide. Therefore, this circle is perfectly in the center. And same deal right here. Let's coincide this as well. So you see the circle turns black. That means the location is fully defined. And now we can cut it to a quarter deep. So the hole is made. Next one is make another hole. And you see the cosmetic thread already being applied. So this hole is a quarter and quarter diameter and 3/4 as depth. So quarter by 3/4. So from here, let's draw another circle. Click the wrong thing to do extruded cut for 3/4. Okay. And if you need to apply the cosmetic thread, please refer to my old recordings. I've showed it plenty of times. It's easy, just 2 more steps. So this time, they want to mirror the entire feature of this rectangular block to the right side. Let's do it. So let's figure it out which plane we can use as reference to make the mirror happen. So it seems like the right plane is the top choice since it's right in the center, right? So let's make that one as our reference and also select everything we just made, all 3 features, because we want to mirror those all together. And mirror these 3, mirror face or plane, and we just discovered the right plane is a fit. And select right plane, and here we go. Let's get back. Look exactly the same. Our next step is a fillet of 0.03 and all around this edges and surfaces. Okay, and let's make it. So select the fillet and just keep clicking. Actually set the magnitude first, 0.03, and just keep clicking all the edges that you wanted to have a fillet. want to see help. So probably this edge is not available. Let's see. Let's get back. So it's really all the edges without the bore. Okay. This edge cannot be applied. Now this face. Okay, let's click OK now. And let's find out why this edge cannot be applied with a fillet. Well, it seems like it can. Geometry and radius values and try to use face fillet option. I'm not trying to fillet a face. It's kind of funny. Let's ignore it and keep moving on. One fillet is not going to stop us. So let's just assume fillets all around this stroke, because fillets are not very important anyway. And chamfers in the bottom of the screw hole. This is something weird. I'm not going to do it. I never make a design that has that equips chamfers inside of the screw hole. So cut extrude. So pretty much this one gonna remove the bottom half of this bore. And let's find out, okay, exactly at the center point. So same deal, let's choose front plane and start sketching from here. And let's make a, yes, use this one. Use the corner rectangle. Actually, let's draw a line. Yeah, so we know where to draw this rectangle. So this dimension, so the dimension of this rectangle doesn't really matter. We just need to make it big enough to cover the stuff that we're trying to remove. So let's click OK and extrude cut it. So let's say it's through all, both, and we cut it, the bottom portion. Okay, and the last feature was hidden. We don't need to worry about it. So this completes the stroke. Okay, so it looks exactly the same except for the fillet, but we don't need to worry about that. Let's move on to the rest of components. All right. So from this point, there is one more piece within the chamber. Let's open this up. This is the, you can call it a connection rod that connects the stroke to the piston head. So pretty much just one circular rod. Let me show the dimension of it without doing it. So 1/2 inch in diameter, 1/2 inch in diameter, 1.88 in total length. So you draw a circle of 1/2 inch diameter and extrude it for 1.88. Okay, and then you have a rod. And the next feature is the chamfer. You put the chamfer on both edges for 45 degrees by 0.06. So chamfers on both sides, 45 degrees by 0.06. But the chamfers are not necessary. This part going to be hidden in the piston head anyway. Nobody going to see your chamfer. And I don't believe this big of chamfer is needed on this kind of connecting rod, realistically. So it's up to you to have the chamfer or not. Just make sure you get this dimension, which is 0.5 diameter by 1.88 in length. All right. Okay, let's close this. And what else? Let's look from the top. So what's holding the cam is this part. So this is a bracket. It's a C-shaped bracket that's going to connect with fasteners. They're going to hold the cam. And let's draw this part. It's very easy. Very simple geometry. So how big is this circle though? This circle is 1 inch in diameter. Okay, and the rectangle is 2 by 1. So it's 2 inch by 1 inch, and the circle is 1 inch in diameter. Let's make that. So let's start making a rectangle. And we know this is 2 by 1. So this is going to be 1. This is going to be 2. And let's have a circle from the center of the bottom line and make it 1 as well. Okay, and extrude. And we're going to select our contour to be this shape. And this shape only. And how thick they're going to be? I forgot. Let's keep it half first. And let's fan out. Up to surface. Okay, this is a weird way to make the first part. Let's find out how thick it is. 0.5. Okay, we'll make the right guess and let's move on. So one set of through hole on the left foot of this shape. Okay, let's do the through hole first. Okay, this is getting strange. Probably this model is made in very old SolidWorks and now the dimensions are not popping up. Doesn't matter. We can measure from here, diameter of 1/4. And how far? 0.5 from the edge and 0.25 from another edge, right? Okay, this one is 0.25. Okay. So quarter, quarter, and a quarter. All right, so select the surface and let's draw circles. Okay, set it to be a quarter from the center to edge. Okay, 2. Okay, 0.25, 0.25, 0.25. 3.25 has been defined, and we're good. And cut it to make a through hole. Let's say through all. So we have a through hole here. And the next feature, another cut extrude. Okay, let's just measure it. So 3/8 as diameter. And center distance is 0.5, so 0.5 as depth. Okay. So select the same origin and make this circle as 3/4. So 0.38. And extrude it to 0.5. So 0.5 as depth. And we made a counter bore. The same as here. And mirror the same, mirror the two holes, mirror the hole with the counter bore to the other side. And similar to the stroke, let's pick a plane that can be a reference to mirror. So right plane, still the right plane this time. So select these two features, the through hole and counter bore, and mirrored it. And mirror face, right plane. And click yes, and we have two set of holes. Actually, we have 2 holes and 2 counter bores. Okay, and decoration, chamfer, 45 degrees by 0.5 on the top, on the 2 edges on top. So right here, we have chamfer here. And select this surface and select this surface. And 45 by 0.5. Okay, 45 degrees by 0.5 inches. And the very last step, make fillet. So 4 edges with half-inch radius fillet. Okay, click fillet. Select this edge, this edge, this one, and this one. So half-inch in radius, 0.5. Click yes. And here we go. This part's complete. So the C-shaped bracket to hold the cam on top of the block. Exactly the same. Okay. Let's move on. Okay, so from top to bottom, this little thing, we're gonna go over as last because they are an assembly before they being assembled into this engine assembly. So you can see they called cam pin assembly. Let's get rid of this. If I select one of that, you'll see that's all three. That's three different components assembled together, and we'll go over it at the end of this recording. So let's move along. There are more holding brackets at the bottom, and there is one fastener that connects to it. The screws, I'm not gonna show you guys how to make it. It's optional. You can make the screw and make it connect to the block, or you can leave it empty, just as this one. This engine assembly has a lot of holes that's not been filled in with screws, such as the top one and the block body, so it doesn't matter. So you want to make the screw, you make your screw and assemble it. If you don't want to, that's fine. So this bracket, let's open it up to see what it looks like. So this is another C-shaped bracket that look more, let's say, look very different, right? Okay, this first step, what they have done, so it's really making a C shape. So this is done by a half circle, right? So radius is 3/4, so diameter is 1.5. And this one radius is 0.5, so diameter is 1, so diameter 1 and diameter 1.5. All right, so this is just the extrusion of half of a ring. And let's make that. So let's make this 1.5. And the concentric circle with 1. And simply just have a line connect to it and trim the stuff we don't want. And extrude this. Let me plane. If I guess it correctly, it should be another. It should be a 0.5, just same as all other brackets. Yep, 0.5. Okay, the thickness is 0.5, and now we're gonna add 2 bosses from each side. So this one is added from the right first. It seems like it's another extrusion of a ring. Let's measure the OD and ID. OD is 1/4 in radius, 0.5 in diameter, and this one is 1/4 in diameter. So 1/4 and 1/2 inch. All right, so let's start with the right side by drawing circles. Okay, this is the center point of the bottom. So this one will be 0.5. And this one will be 1/4. Okay, we have our sketch. Let's see how thick it will go. Wow, another 0.5. Okay, select this sketch and extrude it to 0.5, but in a different direction. So you can click this arrow to flip your directions and click yes this time. So we have one boss on the right side. And here we go, the cut extrude. So this is how to make a counter, this is to make a counter bore of 3/8, and the depth will be 1/8. So 3/8 diameter by 1/8 deep. So select this surface because we want to draw from there and have a circle. Make this one 3/8 and cut extrude it for 1/8 depth. And here we go, we have the counter bore. Another cut extrude to clear the bore of this through hole. So a quarter and all the way through. So pretty much select this surface because we want to draw from there and start drawing a circle. And same diameter as the hole that already exists on the surface. And let's extrude cut it. You can say through all, so it will go all the way down. A very clear bore. One more step is to mirror this to the left side. So same deal that happened from the beginning of this video. Which plane is suitable for mirror? The right plane, apparently. So let's select pretty much all the features that we want to, select all the features that we want to mirror at this one time. All three being selected in the mirror and put it respect to the right plane. All right, the preview shows good and we click yes, and here we go. And very last step is some decoration, the fillet. So fillet of 0.01 and around all the edges. So select this fillet and just start clicking edges. And set this to be 0.01 so you have a very nice preview right now. I really don't like doing this. But anyway, you know what it's gonna look like at the end, right? So finish it, and if you get stuck by fillet, it doesn't matter. So don't struggle and don't waste your time if you don't get it right the first time. So fillets are all options. All right, let's move on to another bracket. So this bracket look a little bit different than the one being installed on the black body. So this, let's open it up, is also a C-shaped one, but it's wider. So pretty much this is the shape that we get rid of from the stroke. All right, remember the stroke at the bottom, we made an extrude cut to remove some material, and this is exactly what we removed. All right, let's start a new part and let's do this. Okay, so see what I'm talking about is pretty much the stroke. You make that stroke and all the way till the last second step. So this is when you have stroke before you cut the bottom part out, right? And in this case, you cut the top part out. All right, you see? So generate a rectangle on top, which is big enough for which is big enough to cover the entire top area, and then cut it. And that left you this bracket. All right, so if you have any problem to make the stroke, please refer back to the beginning of this video and you will know how to make a stroke till this point. Once you have this step right here, you just draw in the middle plane and then draw a big rectangle that's big enough to cover the top of this stroke. And then you can extrude cut it. So that's gonna left you with this bracket. So I'm not gonna show I'm not gonna show how to make a stroke again. All right. So this is what it is. All right, what else need to be covered in this assembly? It seems like we have covered everything except for this little assembly. Oops. Okay, it's called campaign assembly. Let's open this up. Yep, so this little valve right here, it contains 3 parts. So first part is called campaign, and another part is top, and another part is the spring. So let's start with the pin first. This pin is very easy, just one very simple revolve and one chamfer. The dimension of this revolve is it's an L shape. Length is 1.5 and diameter is 0.38. Thickness on the top is 0.06 and at the bottom is 0.03. Let's take it down. .5. Okay. Okay, from front plane, let's start sketching a center line because we're gonna deal with revolve. So we need a center line as our axis. And let's start draw 2 rectangles because we need a L shape, right? All right, so from top to bottom, the total length is 1.5. The top thickness is 0.06. And thickness at the bottom is 0.03. And from here to here, we're gonna make it, it says the diameter is 0.38. So this actually will be the radius, right? Because you're gonna be revolved, so it's 0.38 divided by 2. And now let's trim this piece that we don't want it. Okay. So 0.38, which is divided by 2 at the radius, and 0.06 and 0.03 and 1.5, they're all on there. And now we can revolve it. And it already picked the center line for us. And 360 degrees, and click yes. And here we have the body of this pane. And there's the chamfer. The chamfer is 1/8 by 45 degrees by 1/8. So let's apply the same chamfer. So 45 degrees by 1/8, which is 0.13 or 0.125, whatever. You click yes, and here we go. We have the ping. 2 steps. And let's go with the top at the next. The top is 2 features as well. So first one, this is just like a wheel. Let's measure this. So ID is 1/8, OD is 3/8, and thickness is 1/4. So 1/8 and 3/8 and 1/4. Okay, let's make it. Front plane. So 1/8, 3/8, and extrude it to 0.5 as a 0.25. Okay. So we have this little wheel. And now we're gonna close it on top by a semisphere. So how to do that on this part? Let's select the top surface and we're gonna sketch it, a circle. Exactly match the OD, which is 3/8, right? So once we have the circle, let's do a center line. And let's do another real line. So after the center line, let's do a real line. Because we only want the half of the circle. So now we can trim the another half that we don't want. So we have a perfect half moon geometry right here. And we can now, once you have this half moon geometry, you can go revolve and respect to the center line that you just made, which is automatically picked for you. And instead of going 360 degrees, we want to modify this to go only 180. And you can select this. You can reverse direction by clicking this button. And once you've done that, only go 180 degrees, click yes. And this is how you complete this little hat of the valve assembly, I believe. So if you come back and see it, look exactly the same. Okay. And the last part will be the spring. And let's open up the spring, and it's just a spring and the spring alone. So how to make that? The first feature called helix and spiral. So pretty much, I don't know why SolidWorks divided these two helix and sweep into 2 features. In Creo, we just have one called helical sweep. But anyway, it worked based on the same principle. So let's find out this feature and grab the parameters from this feature. So the height is 3/8. Let's take it down. And revolutions 6. And start angle 90 degree. So pretty much, as you can see, actually, yeah, let's start from here. The diameter is 1/4, and we're going to take that as well. So I will explain while I'm making this part. Let's close this. And let's make a new one. So first of all, select one of the plane and ready to sketch, right? And right here, you type in helix, like what I did, and search. And the first one pop out, and the only one is helix and spiral. And you select it. And now you might notice you're automatically in the sketch mode. And in order to have a circular spring, we need to start drawing a circle, because this is the footprint of the spring. And how big of the circle? We took it down the diameter of 1/4. So let's put it as 1/4 and click yes. And now, once you have the once you have the circle, you can access sketch. And that's gonna automatically jump into the setting of this helix. And the height is automatically filled in. So if you don't have it filled in, is 0.375. And revolution is 6. And start angle 90 degrees. And you click yes, and you'll notice a wireframe of the spring already been created in front of your eye, and that's where you're gonna swip it based off. So pretty much you jump to feature. We're gonna do the same thing, just similar to extrude or revolve, but this time we're gonna do swip. All right, so this is your geometry. We're gonna swip based off this geometry. And right here, sketch profile. That means if it's not a circular shape, for instance, if you want this spring to have like star profile or square profile, you can sketch it on the tip of this point right here. You sketch a geometry and you're gonna swip that geometry along these spirals. But this time we just want it to be circular. And select the circular, and you notice the preview is already look pretty decent for spring, but this one is too big. The correct dimension is 0.06. So I believe it's like 1/16. So after you punch in 0.06, you'll see your spring is ready. And click yes, and you have a spring here. All right, this look exactly like this. And don't ask me why there are lines in between. I don't know why, because this assembly probably done in the version of SolidWorks that was 10 years ago. There are a lot of things are off. But anyway, the final geometry and dimensions are the same. And now you can put all 3 parts into an assembly, which is called that cam pin assembly. This one. And then you can start putting this assembly into your engine assembly. So pretty much this completes the engine assembly. I went over every single component except for the fasteners. And in fact, there's only one fastener, one screw going into this hole right here, and the other holes are vacant. So I'll say this is as far as I can help, and the rest of work, like mating parts and putting parts together and to make your engine assembly look exactly like this one, is your job to do it. All right, and that will be all for this video, and I'm gonna end this meeting, and I'll see you guys all in the next class. Thank you. Bye.